Okay, so today I'm gonna share some insight on electronics. So today we'll talk about LEDs. All this time I worked with electronics and I'm just a beginner though, just learning phase. But still I never took into account to learn in depth about the LEDs. So today on a flashlight project, I came across this concept here and this seemed so wonderful. So I thought, why not share it with everyone else? So LED stands for light emitting diode. This is a special kind of diode. So we know that diode in general refers to a combination of a PN junction. So PN N-type semiconductors forms a diode. Um, this junction here creates a depletion layer, basically a voltage barrier. So for silicon diode it's like 0.7 volt, and for germanium diode it's 0.3 volt. What this basically means is, if say for example we have a circuit here, so um, we want to measure the current flow. So the current flow, and we have the 2012 volt here, and suppose uh, let's just scrap it. Let's just say this is our voltage source, and this is variable voltage source, and this is the ground. So the current should follow this path and go through the PN junction and um, go to the ground. So considering the PN junction is um, connected in forward bias mode. So basically what forward bias mode refers is the P part goes with the positive and the N part goes to the negative side of the circuits. So here we said the voltage source is variable. So if let's say we start from 0.1 volt, now even though we have a voltage here and we might be thinking that current should flow, but before, if we are using say a silicon diode, so before reaching 0.7 volt we will not see any current flow, because this voltage barrier could not be break without the 0.7 volt minimum. So for the current flow we have to set at least, at the very least, 0.7 volt, and we can then ramp this up to say 5 volt or anything like that. So this basically shows the applications of PN junction or diode in general. Now LED on the other hand are a special kind of diode. So the symbol for diode is this, where this represents the positive side, the P portion, and this negative portion. And for LED we just say these two arrows, three arrows. This basically means the light emitting. So that's how the name came, light emitting diode. And LEDs are a special kind of diode because they they are not linear. So first of all, they are not linear components. So what does linear components mean in electronics? Linear components means the current flows is proportional to the voltage difference across the device, across the electric device. So here we cannot say the current passing through this LED. So I is not proportional. We cannot say I is proportional to V. Say we have here V1 and V2, and our V is equal to V1 minus V2. So this is basically the voltage difference. So we cannot say that. So this is not valid for here. What is valid for this scenario is a proportional exponential term. So I is exponentially proportional to the voltage differences. That's why when you connect this, let's just create a circuit, for example, here. So let's say we have this, and this is basically an LED connected directly to ground, and let's say we're providing positive, say 5 volt, and LEDs generally have voltage. LEDs generally have a voltage rating like 3 volt or 5 volt. So 3 volt is most generic. 3 volt to 2 volt. 2 volt is also very popular. So this rating basically indicates that if we place a LED directly with the source, so uh, this will subtract this amount of volt. Say this is 3 volt, so 3 volt. So in this position, say we will get a 2 volt. So 5 volt is the voltage source, and 3 volt is reduced by the LED here, and we will get 2 volt down there. And because of this, the resistance is also not fixed of an LED. So we cannot say that our LED is fixed. Our LED is not fixed. So this is not a constant amount. These are depends on the voltage. So if we increase the voltage, these are becomes larger or smaller. This can vary because it is not linear. So here an LED has also current ratings. Suppose 20 milliampere or 10 milliampere. So this is the maximum current rating. So if we pass more than this amount of current, the LED will burn. So my basic question was, why do we need to place a resistor in series with LEDs? I see in all circuits that we use a resistor, and this resistor is also called current controlling resistor. So why it's called current controlling? Where the controlling part comes from? So what I found is that as we saw that if we connect this in this configuration, as the R is not fixed, so we cannot just say that we cannot just calculate the current flowing in the circuit. So we know that current's formula is I is equal to V divided by R. So as we don't know the R, so we cannot verify the I. So this can cause a massive current flow, and the LED could burn down. So we need to control this current flow. Typically the resistor is near zero of an LED, near zero. It is very small, in range of 10 to the power minus 3 range, most probably. So to control this, we connect a resistor in series with the LED, and let's say we are providing here 5 volt, for example, and the LED is of 3 volt rating, and this is just ground. So what we have here is for this resistor, basically we have a working 2 volt. So 5 volt subtracted by 3, we get 2 volt working voltage here, down here. So Now we can calculate, and just let's say that the RLED is near 0, so this doesn't really matter. R1, so what we know is our total is equal to R1 plus RLED, and as this thing is changed to 0, so we can just say this is equal to R1. So how do we calculate this current emitting resistor? Suppose we want to flow 10 milliampere current here, as we want 10 milliampere current down there, so we can just say like I P by R here, 10 times 10 to minus 3 for this m portion milli, and the V here is 2 volt, and we have to calculate the R. Now we can see that this roughly calculates to the, so 200 ohm. That's how, by placing this R on is equal to 200 ohm, we can safely control the current flow here in this circuit, and the I will be say 10 milliampere. So 10 milliampere. So that's how we can control the current. Here there will be some a little bit of current loss though, now in form of heat. So that formula would be I square R1 times T, for T times this is the heat generated by this resistor here, so yeah, that's it. That's how we can control the current of an LED using a resistor. And because the current solely depends on this resistor, so resistor is the only variable in this circuit, that's why it is called the current controlling resistor. Yep, that's it. Hope you enjoyed.